Have you ever pondered the mysteries of the universe, its infinite expanse, its countless celestial bodies, and the laws that govern them? It's a vast cosmic playground, filled with enigmas and revelations. Among the stargazers who have sought to unravel these mysteries was Galileo Galilei. His revolutionary discoveries altered our cosmic perspective, shifting our understanding from an Earth-centered to a Sun-centered system. One of these celestial bodies, a moon of Jupiter named Io, has its own unique story that has reshaped our understanding of our solar system. In the year 1610, Galileo Galilei peered through his telescope and made a discovery that would forever change our understanding of the universe. Through the lens of his rudimentary telescope, Galileo spotted 4 bright points of light orbiting Jupiter. These were none other than Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto, now known as the Galilean satellites. Among these celestial bodies, Io stood out for its vibrant colors and dynamic surface. But the real revolution was not just in the discovery of these moons, but in what they implied. The moons were clearly orbiting Jupiter, not the Earth. This observation was a direct contradiction to the prevailing belief of the time that everything in the universe revolved around the Earth. This was a paradigm-shifting realization that sparked a new era in astronomy. Galileo's discovery was a monumental leap forward in our understanding of the universe and paved the way for further exploration and discovery. Among the celestial bodies Galileo discovered, Io holds a special place. It is the most volcanically active body in our solar system. Not just a few, but over 400 active volcanoes dot its surface, spewing clouds of sulfur and molten rock up to 250 miles into space. It's a world ablaze with volcanic vents, lava flows, and high-reaching plumes of fiery spectacle. But what causes this fiery dance? The answer lies in the gravitational tango between Io, Jupiter, and its neighboring moons. This celestial ballet generates tidal forces that churn up a prodigious amount of heat within Io, keeping much of its subsurface crust in a liquid state. This molten rock seeks any available escape route to the surface to relieve the pressure, thus renewing Io's surface constantly, filling in any impact craters with molten lava lakes and spreading smooth new floodplains of liquid rock. In terms of size, Io is the 3rd largest of Jupiter's moons and the 5th one in distance from the planet. Shaped by the relentless forces of gravity and heat, its landscape is ever-changing, an alien canvas painted by the brush of volcanic activity. Yet, for all its fiery grandeur, Io's constant volcanic activity and intense radiation make it an unlikely destination for life. But it's a place that continues to captivate us, as it holds invaluable information about the workings of our solar system. Io isn't just a fiery spectacle, it also plays an intriguing role in Jupiter's magnetic field. Pivoting around Jupiter, Io conducts an electrifying dance with the gas giant's magnetic field. As Jupiter rotates, its magnetic field sweeps along, dragging with it a wave of charged particles from Io's volcanic emissions. This material becomes ionized, forming a donut-shaped cloud of intense radiation known as a plasma torus. But the show doesn't end there. Some of these ions are pulled into Jupiter's atmosphere along the magnetic lines of force, creating a dazzling display of auroras in the planet's upper atmosphere. It's a mesmerizing spectacle, a cosmic ballet of charged particles and magnetic forces. The relationship between Io and Jupiter demonstrates the intricate dance of celestial bodies, where even a moon's volcanic activity can influence the atmospheric phenomena of its parent planet. This interaction paints a fascinating image of the complexity and interconnectedness of celestial bodies within our solar system. Io's unique characteristics and its interactions with Jupiter make it a significant body in our solar system. This moon, named after a mythological character in a celestial soap opera, is a hotbed of volcanic activity. Its ever-changing surface, constantly renewed by molten lava, provides a unique study in planetary geology. But it's not just the volcanoes that make Io interesting. It's also a key player in the magnetic field of Jupiter, the biggest planet in our neighborhood. As Jupiter spins, it drags its magnetic field around, ensnaring Io and creating a plasma torus, a donut-shaped cloud of radiation. This interaction also leads to the creation of dazzling auroras in Jupiter's upper atmosphere. It's a celestial ballet of epic proportions. By studying Io, we get to understand more about magnetic fields, tidal forces, and the dynamics of our solar system. Studying Io not only provides us with a deeper understanding of our solar system, but it also reminds us of the infinite mysteries the universe holds, waiting to be discovered.